Hello everyone. Today we are going to discuss about problems on fragmentation in IPv4 datagram. Here the problem is we have a large datagram of size 4000 bytes and we need to transfer it through a router which is having a maximum transmission unit value 1500 bytes, and in order to do this we need to know the number of fragments. To know that, we have a formula: number of fragments is equal to length of the datagram divided by MTU, that is equal to 4000 divided by 1500, which gives the approximate value as 3. That means we can fragment this large datagram into 3 sub datagrams, which is also having a header similar to that of a large datagram, which is of 20 bytes, and we transfer it through our routers. These datagrams will transfer in a multiple routes of network and finally reaches the destination where the reassembly of the fragments takes place. As I already told, there are 4000 bytes datagram which we need to transfer through a router which is having MTU value of 1500, and this implies that the 3980 data bytes in the original datagram must be allocated to 3 separate fragments, and each of which is also an IP datagram. Suppose that the original datagram is stamped with an identification number of 777, that the characteristics of 3 fragments are shown in the table below. This identification number is useful at the destination where the fragmented datagrams get reassembled. Here, as we can see in there, the datagram which is having 2 parts, which is a header part and a payload part. The header is of 20 bytes and payload of 3980 bytes, and similarly the fragmented datagram which is having 20 bytes of a header and 1480 bytes of payload. Here in the table we are representing fragments F1, F2 and F3, and there is a more fragment which is a flag which indicates the upcoming fragments, and that is if the more fragment represent 1 or set to 1, that means there is an incoming fragment on the way, and if it is set to 0, that means there is no incoming fragments. And header length, which is having both the destination and source address, which is of 20 bytes each, and data bytes or the payload of our datagram, which is of 1800 and 1480 bytes. This is filled according to the total length of the router, that is MTU. Here we are having total payload is 3980, which is divided among these 3 fragments, and the possible length of a datagram is 1480 bytes. So we fill the completely in the fragment 1, and in the second also we fill the completely, but in third we fill the remaining portion of the payload after subtracting 1480 and 1480 of fragment 1 and fragment 2, that is 1020 bytes, and total length is obtained by adding both header length and the payload, that is 1480 plus 20 is 1500. And the fragment offset, this is also a flag which indicate the data which is already incorporated or received at the end or receiver side. If it is set to 0, that means there is no data received previously for the same datagram, and if it is set to some number, that means the data is already received related to the same datagram. Here this fragment offset represent the data received, but the actual size of the data is not mentioned here, but the data is represented in the scale of 8, that is by dividing 1480 bytes by 8 we get this number, and similarly for the fragment 3, we already received fragment 1 and fragment 2 payload, so that we add both f1 and f2 payloads and divide it by 8, we get 370. This is how the fragmentation of our datagram in Internet Protocol version 4 is takes place. Thank you for listening.